Today we're going to start talking about the layers of Earth. So we're first going to identify what those layers are and what they're composed of, and then we're going to talk about the importance of these layers. The four layers of Earth are going to be the crust, the mantle, inner core, and the outer core. And we're going to talk about each one of those individually and give you a couple of characteristics about all four. Let's start with the crust. The crust is very, very thin. It is the outermost layer of Earth. It is actually what you walk on when you're outside. So when you're walking on the grass or the dirt, you're walking on the crust. The crust is made of different rocks, which we're going to talk about later on in our Earth unit. Those rocks are going to be igneous rocks, metamorphic rocks, and sedimentary rocks. And right now that means nothing. But we're gonna look at those. We're gonna actually be able to hold some of those types of rocks and look at them. Basically, think of the crust as the skin of an apple. It's very, very thin. The other layers are more, or bigger. And so this particular layer is thin, making up 1% of Earth's volume. So that's very small. The crust is the coldest layer because it's exposed to the atmosphere. So basically, if we compare it to the mantle, the inner core, and the outer core, those layers are actually warmer than the crust. All right, this is a picture of the crust, the mantle, the outer core, and the inner core. So just taking a look at how thin that layer is. So that brown that you see around the rim here, that's actually kind of comparing how thin the crust is to the mantle and the core. The mantle is the second layer of Earth and is solid between the crust and the outer core. The mantle makes up about 84% of the total volume. It has two basic sections in it, and those two sections are the asthenosphere and the lithosphere, and those two make up the mantle. So when the mantle is warmer than the crust, and later we're going to talk about how the mantle creates these convection currents because of how warm it is. But it is the second layer of Earth, and it's solid between that crust and the outer core. The outer and inner core. So let's talk about the outer core first. The outer core is a magma-like liquid layer, and that layer is going to surround that inner core, and it's going to create or help us to create Earth's magnetic field. And we'll talk about the magnetic field in just a second because that's important to Earth. The inner core is the final layer, and basically it's a solid ball of metal. The inner core is basically very, very hot, and it's so hot that it melts the outer core into that liquid magma. So that's how the outer core becomes liquid, because of the inner core's heat. Now let's look at the magnetic field. Our Earth's magnetic field is basically believed, and we say believed because this is a theory, to be generated deep into Earth's core. We've never been to Earth's core, so we've never, nobody's ever taken that mythological journey to the center of Earth. But we study earthquakes, which we'll talk about later, through the planet, and basically they've theorized that this core is creating this magnetic field for Earth. Now, we're going to watch a video afterwards, so I'm going to pull this video up later, and it'll be posted on my website so that you can have access to it anytime you need. But both of Earth's inner and outer core are metal, but the outer core remains liquid, while pressure keeps the inner core solid. The liquid outer core is basically constantly moving, and this moving metal generates that magnetic field. So this is all theory. That magnetic field is important to us because it keeps our planet in orbit. It keeps us from basically crashing into other planets. And it basically also keeps heat or too much heat from entering into our atmosphere. So why is it important to us? It's important because it's going to deflect a lot of our radiation. So that magnetic field is important to us. It prevents solar winds from the sun that blow directly into our atmosphere.